I wanted to do this quick video on lesson 3, which was on interpreting and using function notation. I think this is a really valuable lesson because it allows you to interpret a graph and use that graph to answer some questions. So we talked about in class about a drone and what a drone does. And you guys did an amazing job explaining that a drone takes pictures, it flies in the air. And one of the things we talked about in this graph is that you could see that it's the height of a drone in meters, t seconds after it leaves the ground. So this is kind of a replication of what a drone does. So you could see here, it starts off on the ground, it flies up, and then what is known, we talked about this word, it hovers. So it kind of floats in the air without kind of moving, but over time, see, it doesn't go up, it doesn't go down, it just kind of hovers at that certain height. And then it starts to go down. And if I look at this, I can interpret this and know that it started here at time 0. So that means before it even took off, so time was 0. And then when did it land? Well, I can look right here and I can know that it landed at 7 seconds. So that's how you read this graph. So how far, at what height did it hover? Well, all I need to do is draw a quick dotted line over right here. And if I count by ones, I know that this is 1 meter, 2 meters, 3 meters, 4 meters. So reading the graph, this means that it hovered at 4 meters in the air. And how long did it hover for? Well, I can read a graph again. So it started hovering at when the time was 2 seconds all the way. And how did I get that? Well, I basically can look at the graph and I can visualize drawing a dotted line down to the x-axis. Remember, this is the x-axis. So I can draw a line down, and I know that if I look at between the time of 2 and 5 seconds, well, how many total seconds is that? Well, 3 seconds. So it hovered at 4 meters for 3 seconds. So that's how I look and read this graph. And this is really important in this lesson, is to be able to read a graph and answer some questions about it. So let's go ahead and we're going to use the graph and we're going to answer the question. Decide which function value is greater. So now we're going to layer on, and we have to now remember function notation. So again, remember function notation, and I'm going to use F because that's the letter I'm using here. The F is the name of the function. So this is the name. And I'm going to remember that I've got these parentheses, and inside the parentheses, we typically say F of X. So this X, this number inside the parentheses, is the input. That is what I am putting into the function to get something out. So think about the vending machine analogy I used in class. What is the input? It's the money I'm putting into the machine. What am I getting out? Whatever I decide to hit the button for and buy. So in this case, what is my input? Well, it's 0. Well, and what is my input here? It's 4. All right, so what does that mean? Think about, take a look, X. Take a look, X, right there. What is the X measuring in my graph? Right here, it's measuring time in seconds. So this is time. This is 4 seconds. This is 0 seconds. All right, so now let's layer on. So when time is 0, what did I, when I looked at my graph, measure when time was 0? Well, what's the height of the drone? It's also 0. So when time was 0, the height of my drone was 0. Okay, so let's go over and look at f of 4. When the height of the drone at 4 seconds, right here, 4 seconds, what is the height? Oh, I see it's hovering. Remember, what was that amount when it was hovering? 4 meters. So at 4 seconds, it was hovering. The distance was 4 meters. So which was greater? When the height was 0 or when the height was at 4 meters? Definitely 4 meters at f of 4. F of 4 is 4 seconds. The distance for this function was greater at 4 meters. All right, so now, sorry, I'm going to keep drawing on this graph, and I'm going to use a different color. Let's see. How about if I use purple this time? All right, now it says, what's greater, f of 2 or f of 5? So let's think about it. Remember what I said, the input is 2. This means 2 seconds. So we're going to go over and read the graph. F of 2, draw it up. What's the distance that the drone is at? 4. So right here, this is at 4 meters. All I did was read the graph. So now let's look at f of 5. So I'm going to go over here. 5 is my input. It's the time. And I'm going to draw it up. And oh, take a look. It's at 4 meters. So this, at 5 seconds, how high is the drone? It's also at 4 meters. So what's greater? Neither. They are at the same height. They are at same height. So the same exact distance at the same time. All right, so let's see. Do I have anything else to add? Oh, yeah, right here. F of t. So think about it. Is there an input there? Look, is there a number? No, there's not. So what we need to do is just go at any time. Any time. So pick a point. When f is 1, what is it? Well, I'd have to read the graph right here. It's about 2. How about at f of 2? Remember, we answered that question. At f of 2, it's at 4. At f of 3, it's at 4. At f of 4, it's at 4. At f of 5, it's at 4. All right, so you can automatically go, oh, well, if I just add 1, it's always 1 more, right? Yeah, but, take a look here. What happens if I input 6? So what's the height when it's f of 6? Take a look. At f of 6, it's at 2. All right, at f of 6, it's at 2 meters. Because remember, it's going down. Look when it's at f of 7. At f of 7, remember what I said? It landed. It's at time. The time is at 7, but what's the height? It's back on the ground. So it's at 0. The ground is 0. So this right here, it depends. It depends. It depends on what time is. Depends on what time, t or time is. All right, I hope that makes more sense now. So now, all I want you to do, let's just say that that's T. Take a look. Or instead of T, let's make it F. It should be F. F of 3. So think about it. What did F of 2 mean? What did F of 5 mean? It meant, remember, this is 3 seconds. All right. So at 3 seconds, it's telling me that it's equal to 4. Well, F of 3 means at 3 seconds, the height of the drone is at 4 meters. So that is what the function told me. All right. So now, I just want you to make sure that you got all that down and you wrote all my little notes. And I think, and I'm going to actually go back one, and what I want you to remember, this is standard notation. This F is the name of the function. And I want you to remember that the X signifies the input of the function. It is what I am putting into the function. It is typically the variable that you're given. So if I say F of N, this is the input. If I say F of S, this is the input. Okay, so and mathematicians are really great for assigning letters to assigning variables, meaning letters, to represent something in their function. It's what they do. All right, so let me go back. Make sure you get all of that. Stop the video. Put it down. All right, I'm going to skip. That was that page. Skip again. All right, so let's just look at this graph. I want you to read what it represents. Okay, so let's take a look here. It's telling me that this function, and here's the name. The name is W. So the function name is W, so I'm going to write it up here. And it says it gives the depth in inches. Depth in inches. So right here, depth in inches of water in a tub as a function of time, T, in minutes since the tub started being drained. All right, so think about it. You're taking a bath in a bathtub. You fill the water up in the bathtub. Okay? What is the depth of the water before, like, how far did you put the water in the tub? And then you started draining the tub. So we're starting with the water being in the tub and we're draining it. Take a look. Makes sense, right? It starts way up here and it's going down. And then I see that it levels off. So it looks like, I'm just reading the graph. I'm not even going to look at anything right now. All I'm doing to do is read the graph. The depth of the water in inches. I started it here. It looks like it went down. And it looks like it then leveled off. Okay, so maybe what this person did, started with water in the tub, drained it a little bit, and then stopped draining it. Okay, so that's how I'm reading this. And I'm like, okay, maybe they put too much water in. I don't know. Maybe they got doing something. Maybe they're washing their dog in the bathtub and they needed to let some water out because it was splashing all over the place, right? It could be any scenario at all. We can be creative. So I'm just going to erase this because I want, again, to go back and think about it. Okay, function W, name, gives the depth in inches of water in a tub as a function of time. So that means that the water in the tub depends on the time. So think about it. Over time, the water in the tub goes down. So depth of water in inches. Remember, this is the output. This is the dependent variable. Time is the input. It is the independent variable. All right, take a look. T, input. Oh, it says write the function using function notation. So again, I'm going to skip back. I'm going to go back. This is function notation. Remember, I got to put the name of the function at the beginning. I've got to put parentheses, and inside I've got to put the input. Okay, let's fast forward. What's the name of the function? W. What was the input? Take a look right here. What's the input? T. W of T. There it is. There it is. Again, all I did was break it down. Function W right there. Input right there. W of T. The depth of the water in inches depends on the time that we allow to go by. Right? Okay, now, let's interpret. I'm going to erase this just to make it a little bit easier. Okay, let's interpret. Remember, T is the input. W is the name of the function. Uh-oh. I've got an ordered pair there. Take a look. Ordered pair right there. Remember, an ordered pair is X comma Y. And all I'm going to do is I'm going to read the X first. What's the X? The X is 2. 2. Right there. There it is. 2 what? Time in minutes. So, at 2 minutes, comma, what's going on? Here's the Y. Oops, I wanted to change color to red. Here's 5. Here's 5. What's going on at 5? Right there. 5 inches of water. So at 2 minutes, there is 5 inches of water in the tub. That's what it means. Okay, all I did was I broke it down. 2 is the X. I went down and read what is the X? Time, right? What's the Y? Depth. All I did was read the label, put it together. At 2 minutes, there's 5 inches of water in the tub. All right, how about F of 0? Okay, remember, 0, what does it stand for? Input. Right here, look. Input, input, input. What's the input? Time. So, at what? At 0 minutes, meaning we haven't even started to count yet. So at 0 minutes, how much water is in the tub? Read the graph. How much water is in the tub? I'm going to erase this to make it a little bit easier for me to read. Okay, so if time is 0, right here, I'm going to go up. How much water is in the tub? Right here. How much water? It says right there on the graph. 6 inches. So at 0 minutes, meaning before I started draining the tub, that's what 0 minutes mean. I haven't even started to count the number of minutes yet. How much water is in the tub? At 0 minutes, there is 6 inches of water in the tub. All right. So let's see if you could do this one. This one right here, and I'm going to actually pull it up a little bit. Okay. F of t. I just want you to think, what is the input? What is the input? And what is it meaning? Okay, so I hope you got it that, do I know what the input is? No, it's just time. So at some time t, okay, at some time t, what is it telling me? Equals 3. So at some time t, comma, there is 3 inches of water in the tub. All right, at some time t, there is 3 inches of water in the tub. Can we figure out what it is at 3? What's the time at 3 inches? Well, I'm going to go back to my graph, and I am going to erase this, and now I'm going to find 3 inches. All right, so I'm going to read the y-axis. So I'm going to draw my line right there. I'm going to draw a circle around 3 inches of water, and I'm going to run my line. I'm going to run it all the way until the green line hits the black graph. And then I'm going to draw a circle, and then I'm going to go down, and I'm going to find out how much time is that. So at 3 inches, it elapsed at 6 minutes. So at some time t, there is 3 inches of water in the tub. What is that time? So instead of at some time t, we could actually say at 6 minutes, because we read the graph, we got the information, there are 3 inches of water in the tub. All right, that's what it means. Phew, hopefully that helped. I'm going to stop there. I just want to show you the next slides. So this was about interpreting. We didn't do this in class. If you would like to try this on your own, I'm going to encourage you to do it, because what I'm going to do is I'm actually going to fill in this slide, and I'm just going to give you the answers, because I think this is awesome practice for you to be able to do this page where I'm talking about smartphone and the number of people who own a smartphone. Okay, so, sorry about that. So what you want to do is see if you can, and do not do this. I am not going to do 3, but I am going to do, up on top here, A and B, so 2A and B, and this first one, number 1. And this next piece are simply just summaries. They're summaries of what we did, and it's just more information, okay? Even on this next one. Down at the bottom, if I keep going, there are your lesson summary key points. So the most important thing is, can you tell me, what does something like P of 3 equals 12 mean? If I was given a graph, if I was given information, that is what you need to be able to tell us that P is the input, the output is 12. I would be reading a graph. All right, so I'm going to stop the video right there. I'm going to go back, and I'm actually going to put the answers in. I want you to try it on your own. Hopefully this video helped solidify a little bit more information. Okay, I'm going to share with you real quick question number 1 and 2. So the one thing you need to remember is this says year after 2000. So that input, the input is T, which means it is after the year 2000. So P of 17 means 17 years after 2000. So therefore, if I add 17 onto 2000, I get 2017. So it means in the year 2017, 2,320 million people owned a smartphone. That's what it means. All right. Then in this B, it says negative 10. So I want you to think negative 10 means 10 years before 2000. So what was 10 years before 2000? In 1990. So in 1990, which is well before all of you guys were born, 10 years before 2000, in 1990, no one owned a smartphone because it says 0. Can you believe that? So I'm going to go ahead and stop the video. I want you to try number 2. And now we're going to put it in function notation. Remember, f of x, g of x. So I want you to try that on your own. All right, so I hope you saw 2010, 10 years after 2000. So remember, that's the input. 10 is the input. So I would say f of 10 is equal to 296,600,000 people owned a smartphone. And then in 2015, how many years after 2000 is that? 15. So that's the input. So I would say f of 15 equals 1.86 billion, or there's the other big number there. All right, there you go. Hopefully you did well on that. And I'm going to do another video on lesson 4.